Okay, right now in question 2, in question 2, they say that if m equals to 2 sine squared 180 minus theta plus 2 sine theta over cos 2 theta and p equals to 2 sine theta over cos theta minus sine theta. They say that in A1, prove that m equals to p. Now, I want you to first know of the following trigonometric identities that we may just need to use in the question given. Now, the first ones we call them the supplementary ones. Now, we're going to draw a Cartesian plane like this, right? And then we're going to basically use theta, all right? Then here we're going to use 180 minus theta. Here we're going to say 180 plus theta, and then there we're going to say 360 minus theta, and then here we're going to say all. So there's this sentence that we use, so we're going to say all sorry, let me do it in blue. We say that all students take computers. Now what this basically means, it means that sine theta, cos theta and tan theta is positive in the first quadrant, and then in the second quadrant it's only sine theta that will be positive, and then in the third one it's only tan theta that will be positive, and then in the last one, which is the fourth quadrant, it's only cos of theta that will be positive. And then another one that I need you to look at for, we call them double angle identities, right? So these ones are double angle identities, right? Now, according to double angle identities, if sine 2 theta is going to be equals to 2 sine theta multiplied by cos theta, and then cos 2 theta is going to be equals to three identities. The first one is cos squared theta minus sine squared theta. The other one is going to be 2 cos squared theta minus 1, and the last one is going to be 1 minus 2 sine squared theta. Let me check. Yeah, basically these are the identities that we may just need to use in the question here. Now, to do the question, so we are given that m is equals to 2 sine squared 180 minus theta plus sine 2 theta, and that is all over cos 2 theta. Now, to prove that m equals to p, this is basically proving one side being equals to the other. Now, to go to p, it will be hard for us to prove that p is actually equals to m, because we may just need to do a whole lot of manipulation. So let's just now go with m for now, seeing that it may be much easier for us to prove that m is equals to p. Now, if we do that, we're going to say now equals to, right? Now remember that 2 squared 2 sine squared is the same as just saying sine 180 minus theta and all of that into squared, right? Then we're going to say plus 2 theta, and then that is all over cos 2 squared. All right, and then from there onwards, remember sine 180 degrees is going to basically turn to sine theta. All right, so we're going to now say that 2 sine theta, 2 sine theta squared, and we can change that into a 2 sine theta dot cos theta. All right, and then we can say that is all over. And now let's see, and then seeing that there in P we have a cos theta minus sine theta, I think the only one, the most common one, or the most possible one identity that we can choose for cos 2 sine theta, it has to be this one. Because if we choose this one, we're not gonna have that there, or if we choose that one, it will be impossible for us to have that. So the only one that's possible for us that may just give us that, it's gonna have to be this one. So we're gonna pick that one and say cos squared theta minus sine squared theta. All right, and then if we do that here in the numerator, we can take a 2 sine theta as a common factor. Then if we do that, we're going to be left out with sine theta plus cos theta. All right, and that is all over. And now what I want you to see, can you see that cos squared theta minus sine squared theta is basically what is this? They call it a difference between two squares. All right, now remember, according to the theory of difference between two squares, if you are given x squared minus y squared, if you had to factorize that, it would be x plus y, x minus y. So let's just do that for those ones. So we're going to say cos theta minus sine theta, close bracket, open bracket, cos theta plus sine theta, close bracket, and you're going to say equals to. Now can you see that these brackets there and that bracket there is going to cancel out, which is now going to basically leave us with 2 sine theta all over cos theta minus sine theta, which is basically going to be equals to P. Because in P, can you see that we have 2 sine theta minus cos theta minus sine theta? Okay, and then that's how you could have done question 2A1. All right.